Across this whole series, your phone has been computing its own timing to a satellite. Where the satellite is, how far away, how much to advance every transmission. But there's a catch we've quietly skipped. Every one of those numbers has an expiry date. A satellite is moving, so the moment your phone calculates its timing, that answer is already going stale. So how long can your phone trust its own math before it has to refresh? That question is governed by two things: a reference timestamp called epochTime and a countdown called the Uplink SyncValidityDuration. Let's see how satellite 5G keeps itself from drifting out of sync. Start with epochTime. Remember, SIB19 gives your phone the satellite's ephemeris, its orbit, and the common timing advance, the network's share of the delay. But those values are only a snapshot. They are exactly correct at one specific instant, and that instant is epochTime. Think of it as the timestamp stamped on the data. As of this moment, here is precisely where the satellite is, and here is the delay. Everything your phone computes is anchored to that instant. Now, the satellite doesn't stop and wait. So your phone doesn't just use the snapshot frozen. It extrapolates. It takes the position and velocity at epochTime and the drift rate of the common timing advance, and it propagates them forward, moment by moment, predicting where the satellite is right now, a few seconds after the epoch. It's running the orbital physics itself. The further you get from epochTime, though, the more that prediction can drift from reality, which is exactly why there has to be a limit. That limit is the Uplink SyncValidityDuration, broadcast right there in SIB19. It's a countdown, and it starts at epochTime. For as long as it's running, your phone is allowed to trust its extrapolated timing and keep transmitting on the uplink. But the instant that timer expires, the rules change hard. Your phone is no longer considered synchronized, and an unsynchronized phone is not permitted to transmit uplink at all, because if it did, its timing could now be off far enough to crash into other users' slots. So it must stop and refresh. It has to acquire a newer SIB19 with a fresh epochTime and fresh values, and re-anchor everything before it's allowed back on the uplink. This is the safety valve of the entire system. Better to go briefly silent and resync than to transmit with stale timing and corrupt the cell. But SIB19 is only half of your phone's calculation. To work out its own distance to the satellite, your phone needs one more thing: its own position. And that comes from GNSS, the satellite positioning systems, like GPS. In non-terrestrial networks, a valid positioning fix isn't optional, it is mandatory. Your phone literally cannot compute its service link timing or its Doppler without knowing where it is. So think about what happens if that fix is lost, indoors, in a tunnel, in a deep urban canyon. Your phone can still hear the satellite's broadcast, but it can no longer solve the geometry. Its own timing calculation falls apart, and just like an expired timer, it drops out of uplink sync until it regains a fix. And there's a hidden cost here: keeping a continuous positioning fix and rereading system information. Both burn battery. On a small satellite handset, that power budget really matters. Position and time both have to stay valid, so put it all together and you get a loop that never really stops. Your phone reads SIB19 and locks onto the epoch. It derives its timing and frequency and starts transmitting. It keeps extrapolating forward as the satellite moves. Then, before the validity timer runs out, it refreshes, rereading the latest system information, re-anchoring to a new epoch, and continuing seamlessly. The network can also push updated assistance directly through dedicated signaling, not only through the broadcast. Either way, it's a constant cycle of predict, verify, refresh, predict again. Your phone is never just coasting on old data. It's continuously resynchronizing with a target moving through space at thousands of meters per second. That relentless little loop is what keeps you connected to something you can't even see. So that's the last piece of transparent geostationary NTN. epochTime anchors every calculation to one instant. The Uplink SyncValidityDuration is the countdown that says how long your phone may trust its own extrapolation. A valid GNSS fix is mandatory, or the whole geometry collapses. And a refresh loop keeps re-anchoring before anything goes stale. Put together with everything from this chapter, geometry, timing, access, and throughput, your phone can hold a rock-solid link to a satellite 36,000 kilometers away. Next, we do something radical. We take the base station off the ground and put it on the satellite itself. That's regenerative NTN. Subscribe to RANspace so you don't miss it.